The diagnostic engine inside the Fluke 810 is very accurate if the machine setup is correct and the measurements are valid. Entering the correct speed isn't just a suggestion, it is vitally important. In the data on the graph, the diagnostic engine automatically identified the rotating speed of the motor as the largest peak inside the data and uses this to find other vibration peaks and relates them to sources inside the machine. If we give the 810 the wrong speed, it can't identify the peaks to the source and cannot perform default diagnoses. Now that we've explained the importance of machine speed for a good vibration test, let's talk about how easy it is to find the speed. For constant speed motors, just get the speed from the motor nameplate. That's all there is to it. The diagnostic engine will find the actual speed that the motor is running at today. If you can't find the nameplate, then use a tachometer to find the speed. We only need to do this once because there's a plus or minus 4% window inside the 810, which is going to find the shaft speed for all constant speed machines, no matter what they're running at for the test. If the motor speed varies, the 810 will ask for the speed input every time we take a measurement, because the speed could change every time. Don't assume that the speed is the same as last time, because getting the speed right is very important. The diagnostic engine needs a target speed, and then it will find the actual speed for you that the motor is running at today. There are several different ways you can find the speed. Just pick the one that works the best for you. Use the tachometer supplied with the 810. An infrared beam bounces back from the reflective tape placed on the shaft while it is stopped. Use a separate stroboscope. A flashing light stops the rotating component and you see a digital readout of speed. Use a contact tachometer. Place the small wheel on the rotating component and see a digital readout of the speed. You can use a local variable frequency drive panel and just calculate the RPM. You can see the calculation at the bottom of the page. You can use remote flow readout and calculate the RPM, or you can use a local RPM readout and enter it manually versus using the soft keys. Or you could manually adjust the VFD to the highest normal speed, and most maintenance technicians can do this themselves. If the machine has a belt or a gearbox, you'll need to find two speeds, one for the motor and one for the output shaft. Use the same methods that we discussed on the previous slide to find the output shaft speed. If you can find the belt speed, that'll help the diagnostic engine as well. As we close this video, remember the most important step in vibration testing is the correct identification of the speed. If the wrong speed is reported, the vibration tester will not be able to correctly diagnose the machine faults.